Now we will get and understand an output for 120, 132. Let's understand for 132 first. 132 int I is equal to 132. Now let's convert this 132 to binary. What will happen? What will be the value of 132? Yeah, you can use this method. You will go, and I will write this as here 4, 4, and 4. This is 8 bit, 8 bit, 8 bit, 8 bit. And the maximum value which we can have here is, if we write 1000000, then it is 128. Okay. Now we have 128 plus 4. So 4 is here. This bit will be 1. Okay. So this is the value of 132 in the binary. Okay. And hold this value. This is 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, so this is the integer value in Java. This int value 132 is represented as a 4 here. Okay, now we are going to convert this 32 bit 8 for the 32 bit into only 8 bit, that is byte. Okay, so what will happen here? We will surely going to lose some data. We are going to lose some data, that is some not actually this 24 bit is trimmed. 24 bit data is trimmed. Okay, so compiler so this whole data is trimmed, so we will remain with only 8 bits, the least significant 8 bits. Okay, so we will not have these bits, means these bits will be removed. Okay, now we are left with only these 8 bits. Now what is 132? What we see here is the binary value of 132 we see here. Here in case of 132, while converting to binary, we are having this most significant bit as 1. So as I had already told you that in case of 1, if this most significant bit is 1, then we are going to have a negative number, and if it is 0, we are going to have a positive number. Okay, so in the output, in the console Eclipse, in the Eclipse console where we saw the output for 132, we are going to have, because of this significant bit, this most significant bit as 1, we are going to have a negative number, means in console we will have this minus sign. Okay, now we will, and what will be the output, what will be the magnitude here? We will calculate the magnitude. Okay, means what will be the value here, minus of what? So for that we will calculate here. Okay, for that we will calculate here. So before going to that, I will let you know, understand the concept of two's complement. What is two's complement? Okay, before understanding that, we have to understand the two's complement. Two's complement is simply, first of all, if we have any binary number, we have to invert the bits. After that, add 1 to that. Invert the bits. Second, add 1. This is the number. The output will be, after that, the output of the binary number will be a 2's complement of that number. Okay, suppose in example we have 0, 1, 0, 0. In this case, what we'll have, we will have, we first of all we will invert the bits 1, 1, 1, 1, 0, 1, 1, 1. Wherever it is 1, we have to make it 0. Wherever it is 0, we have to make it 1. And now we will add 1. 0, 0, 0, 1, 1, 1, 1. Okay, now this value is the 2's complement of this number. So in case of this 2's complement, we invert the bits and add 1. Now as I already told you that in this case, where I have already seen that in Java, byte is of size 8 bits and it is always in 2's complement form. So this number is already in a 2's complement. It means that it is already in this form. It is in the form of 2's complement. So to get the magnitude which is here, we have to reverse the process, we have to reverse the process. Okay, to reverse the process of the 2's complement. So how will we reverse the process? In the 2's complement, what we used to do, we first of all we invert the bits and then add the process. In the reverse, we will first remove one. First we will minus subtract one. After that, we will invert the bits, the reverse process of it. So we will first of all we will let me write it here clearly: 1 0 0 0 0 1 0 0. Okay, we will first of all we will subtract 1. So the subtraction goes the same way as decimal, it will carry. So 1 0 here, 2 minus 1 1 1. Here we will have 0 0 0 0 0 1. Okay, so we have subtracted. Now we will subtract it. Okay, now we will reverse the bits, that is invert the bits. Okay, we will invert the bits. How inversion goes? In case of 1 we will write 0, and in case of 0 we will write 1 1 1 0 0. Okay, so this is the magnitude. Okay, this is the magnitude. Now you can see here 0 1 1 1 1 0. Okay, so this the decimal value of this value will be going to show here. So let's convert this value. What will be here? 0 2 4 60 4 8 16 32 64. So we will add this value: 64 plus 32 plus 16 plus 8 and 4 12. This is 28 plus 32, it is 60 plus 64. So we are going to have 124. Okay, 60 124. So here we are going to have 124. So you see this was the same output which we had seen there in the computer. Now I think you got the concept of what is 2's complement, and how it works, and how we can convert int to byte, and where the remaining data, that is 24 bits, are trimmed. So you got I think you got the whole logic, the same thing. Okay, now for 128 you can do by yourself. If you are having any confusion, any problem, then you can leave a comment in the comment section. Okay, I will be helping you there. Okay, thank you very much for being with me. If you have any doubt, then tell me in the comment section. Okay, thank you.